Good afternoon, everybody. My name is SIR-MuCOT Timothy. In this video, we're going to be solving some examples in arithmetic progression and geometry progression. We have learned theory so far, so we want to do the practical terms now. So now, I'll be solving two questions from these four questions, and I'll make it as clear as possible. So now, the first one says, find the nth term of a series if the sum to n terms is 2n squared plus n. So now, I'm going to explain some things before I solve. Let's take for instance that the sequence we are dealing with is arithmetic progression. This equals to A1, A2, A3 down to AN. Now the first term here is A1, the second term is A2, the third term is A3, down till the last term, which is AN. Now, how many terms do we have in this sequence? We have n terms in this sequence, but this particular term here is the nth term. That particular term is the nth term. So we're asked to find the nth term of a series, and when we're talking about series, we're talking about addition of terms in a sequence. So let's take for instance that the series we are talking about is what is this. Let's say A is arithmetic progression, A plus D, A plus 2D, A plus 3D, down till A plus n minus 1D. Now, I want to show you something again. The sum of the first term is what? A. Sum of the first two terms is A plus D. Sum of the first three terms are A plus D plus A plus 2D, down till sum of the first n term equals A plus D plus A plus 2D plus plus A plus n minus 1D. Now we're going to do another thing. We say S2 minus S1, S3 minus S2. So now we're going to be left with what? This is A plus D minus A. So this and this, they are going to take care of each other. Now this one is what? A plus D plus A plus 2D minus A plus D. This and this are going to take care of this and this respectively. So now, what do we observe? What are we left with? We are left with what? A plus D, and we are left with what? A plus 2D. And A plus 2D is the third term, A plus D is the second term. So when we subtract the sum of this, for example, now we subtract the sum of the first term from the sum of the first two terms, we have what? The second term. Meaning, when we subtract the sum of the first 9 terms of a sequence from the sum of the first 10 terms of a sequence, we are going to have what? The 10th term. So that is going to help us a lot in solving this number one question. Number one question, we are asked to find the nth term. So, but they have given us what? The sum to n to be equal to 2n squared plus n. They have given us the sum to n to be this, and we are asked to find the nth term. So we are going to look for a number that when we add the common difference to it, it is going to give us what? The n terms. And we know that we have n minus 2, we have n minus 1, before we have what? N. But n minus 1 is closest to n, so we use what? N minus 1. What are we going to get again? Remember, we are dealing with what? Series. So everything we are going to do is going to be in what? In series. So now we find the sum to n minus 1 of this. Since the sum to n is this, we find sum to n minus 1 of this again. So we now have 2. Anywhere we see n, we replace it with n minus 1. N minus 1 all power 2 plus what? N minus 1. So now we open this bracket to have what? This is 2 bracket n square minus 2n minus what? Plus 2 plus 1, then plus n minus 1. So now n minus 1 is going to give us what? 2n square minus 4n plus 2 minus n minus what? 1. So what we're going to have here now is this is 2n square minus 5 n minus 5n plus 1. So now say Sn minus Sn minus 1. Remember what we did and what I said? So when we remove, we are going to have what the nth term, that's what we're going to get now. So that means that this is going to be 2n squared plus n, now minus everything that is here, 2n squared minus 5n plus 1. So this is going to give us 2n squared plus n minus 2n squared plus 5n plus minus 1. So this is going to give us 2, okay, this and this will cancel each other, now this. Now what is it going to give us? What is it going to give us? So now this is going to be, is there a mistake here? This is 4 minus 4 plus n. This is plus n to give me minus 3n. Here I have minus 3n. So here is minus 3, okay, 3n. So now 3n plus n now is going to give me 4n. So 4n minus 1 is my answer. 4n minus 1 is my answer, and that is the answer to this. So now here, this is the nth term. This is the nth term. Why this is sum to the n? This is the n minus 1 term. This is sum to n minus 1 term. So that is it. That is how I managed to solve it. So without wasting our time again, let's go over to the next one. The next one says that we should find sum to the first 5 terms. So meaning that in Sm we have what? A1, A2, A3, A4, then A5. But here they give us only 1, 2, 3, 4. Now we have S. Since it is sum to first 5, we have used S what 5 to be equal to 1 plus 1 over 5 plus 1 over what? 25 plus 1 over 125 plus 1 plus the rest. So remember what we do. This is the geometric progression. This is an exponential sequence. Yes. So what we're going to do is we divide the first one by the second one, meaning 1 divided by 1 over 5. Abi, what are we going to get? We're going to get 1 times 5. Now we divide this one again by this one. Now 1 over 5 divided by 1 over what? 1 over 25. We have 25 over 5 to be equal to what? 5. So the common difference, the ratio there is what? Is 5. But when you multiply 5 with this, it's going to give us 5 over 5 and 5 over 25. No, so now the answer, the common difference here is what? Is 5, 1 over 5. Because when you multiply this one with 1 over 5, you get this one. You multiply this one with 1 over 5, you get this one. Multiply this one with 1 over 5, you get this 1. So since our ratio is 1 over 5, we do what? We multiply 1 over 125 by what? 1 over 5 to get the fifth and the last term. So that is going to give us 1 over 625. So our last term is 1 over 625. And using sum of a GP to be what? A bracket 1 minus P n all over what? 1 minus P, or we use Sn equal to what? A bracket P n minus 1 over P n minus 1. So this is what we're going to be using. Let us use this one first. So what is our first term? Our first term is 1 bracket 1 minus, what is our constant? Our constant is 1 over 5. So we have 1 over 5 raised to the power. Which, how many terms do we have there? Is 5 terms. That's the power of 5. So all over 1 minus 1 over 5. So now this is going to give us this. We'll solve the bracket first. We have 1 minus 1 bracket 1 raised to 5 raised to the power of 5. This is 5 times 5 to give us 25 times 5 to give us 125 times 5 to give us 625 times 5 to give us 3125. Give us 3125. So now we have 1 minus 3, 1 minus 1 over 3, 1, 2, what? 5. All over 4 over 5. So now this is going to give us 1 minus 1 over 3, 1, 2, 5 over 4 over 5. So now we have that Sn is equal to 3125 minus 1 all over 3125 over 4 over 5. So now we have what? 3124 over 3125 divided by 4 over 5 to give us 3124 over 3125 times 5 over 4. So this can divide this. When 5 divide itself, we have 1. Then 5 divide 31, we have what? 6. 5 divide 12, we have what? 2. 5 divide 25, we have what? 5. Now 4 can divide, 4 divide itself 1. 4 divide 31, we have what? 7. That is 28. Divide 12. Divide 31, remember 3, right? Divide 32 is 8, and we'll have 1. So our answer is this. Let's check if we're going to have the same thing here. This is what? A. This is, I'm going to be fast here because almost everything that is here also. P raised to power n is what? P raised to power n is what? 1 over 5 raised to power 5 minus 1 all over what? 1 over 5 minus 1. So now this is going to give us what? 1 over 3, 1, 2, 5 minus 1 over what? Minus 4 over 5. So now this is going to give us minus 3124 over 3125 over minus 4 over 5. So we arrange again. Minus 3124 over 3125 divided by minus 4 over 5 to give us minus 3124 over 3125 multiplied by 5 over what? 4. Multiplied by minus 5 over 4. And minus is going to give us plus. So this will take care of this. So now this divide this again, this divide this again. We will now have what? 781 over 625. So meaning that the two of them give us the same answer, and this is where I wish to stop. Any further correction or question, you can put them down in the comment box below. Thank you very much and do have a nice day.